Welcome to Past Marathon, Predictive Analytics Use Cases. We're excited you could join us today for Brad Llewellyn's session, 4 Paths to Data Science Success Using Microsoft Azure. This past marathon consists of 5 consecutive live webinars delivered by expert speakers from the past community. The sessions will be recorded and posted online after the event. You'll receive an email letting you know when the recordings are available. My name is Mark Ginnebaugh. I'm as your moderator today. I am a Microsoft Data Platform MVP and Microsoft Regional Director. My day job is as CEO of DesignMind, which is a Microsoft Gold Partner for data analytics based in San Francisco. I've got a few introductory slides before I hand over the reins to Brad. If you require technical assistance, please type your questions into the question pane located on the right side of your screen and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read your questions aloud to the speaker. You're able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. This will pop up after the webinar ends in your web browser. I'd like to take a moment to thank our presenting sponsor, Kingsway Soft. The staging of Past Marathon would not be possible without their generous support, and they are the reason this event is available free of charge. If you would like to learn more about our sponsors and sign up for information on how they can help you, please visit sponsors page of the Past Marathon website. Past Summit is the Past community's flagship event, and it is happening November 6th through 9th in Seattle, Washington. Past Summit is the largest conference for technical professionals who leverage the Microsoft Data Platform. Immerse yourself in deep dive technical sessions, learn best practices, and discover new tips and tricks. For more information and to register, visit pastsummit.com. I'm going slightly off script here, but I've attended the last 10 Past Summits. It's a fantastic conference. I highly recommend it, and I hope to see you there this fall. Brad Llewellyn is a senior data science consultant at Centelli Solutions in Charlotte, North Carolina. Brad helps individuals and organizations unravel the data science world in order to figure out how it can work for them. He has a master's in science and statistics from the University of South Carolina, MCSE certification in data management and analytics, MCSE certification in cloud platform and infrastructure, and MCSA certification in machine learning. Brad is an active blogger at breakingbi.blogspot.com. He's also an organizer for the Charlotte BI Group, a local Past chapter in Charlotte, North Carolina. You can connect with him on LinkedIn and on Twitter at breakingbi.
Well, thank you for that great introduction, Mark. Welcome, everybody. This session is 4 Paths to Data Science Success Using Microsoft Azure. As you said, my name is Brad Llewellyn, and what I love to do is really help people understand what data analytics is and really how it can work for them. So I'm really hoping that's what everybody gets out of this session today. So the main question of this session, what we're going to ask over and over again, we're going to step into the shoes of a consultant, and we're going to go into a fictitious company. And in that company, as consultants, our job is going to be to answer this one question. What's the easiest way to solve this business problem? In our line of work, there are no technical problems. There are only business problems. And technology is just one way to solve those. And that's what we're going to look at today. So when we look at what the easiest way to solve a problem is, we first need to identify what does easy mean. So let's talk about what a typical customer's primary concerns are. So first and foremost, when we propose any solution to a customer, the most important criteria is always, will it actually solve the problem? At the end of the day, the solution we recommend has to actually solve the problem it's designed to solve. After that, we get to the cost. Say, how much will the solution cost for us to implement it? Right alongside that, how long will it take? Because in most organizations, time is money. On top of that, one of the ones that doesn't often get thought of is how much is it going to cost to maintain it? And in this realm, cost means two things. One, when we're looking at Azure, resources themselves have costs. If we're going to use an Azure SQL database, that has a cost tied to it. But we also have a cost when we look at human resources, meaning if I need a DBA to maintain the solution, I have to be able to pay that person's salary and their benefits and all that sort of stuff. So we have to keep that in mind as well. And then finally, how quickly does the solution adapt to changing requirements? Whatever our requirements are today, they are almost guaranteed to not be the same tomorrow. So our solution needs to be flexible and extensible to the point where whatever those new problems are we find tomorrow, this solution still works. So with this in mind, let's talk about what our agenda today is. We're going to look at a number of different tools, and we're going to talk about what their strengths are and how they could be used to solve quote unquote data science problems. Typically in my presentations, I like to define what data science is ahead of time. I'm specifically not doing that here because inevitably, when I walk into a customer site, whatever they think data science is not the same thing I think data science is. It's not the same thing another customer thinks data science is. So instead of clinging to those buzzwords and our preconceived notions, one thing we're going to do a lot here is we're going to dig deeper into their requirements and figure out what are they actually looking for. Because it may not be what you or I think of as traditional data science, but it's still a problem they want to solve. And the tools we're going to look at to do that are Power BI, Cognitive Services, my personal favorite, Azure Machine Learning Studio, as well as the traditional data science tools of R, Python, and HDInsight. So with that, oh, my mistake. These tools all belong to a set of tools in Microsoft called the Cortana Intelligence Suite. And the Cortana Intelligence Suite is Microsoft's big offering around everything data and analytics related inside Azure. So with that, let's take a look at our business problem. So I'm going to give you, say, 45 seconds or so to read through this. So this says that Contoso Beverage Company, also known as CBC, is a large beverage distribution company in the United States. Their main source of revenue is selling cases of soda, tea, and other beverages to customers all over the world. So they're a retailer. Customers can place orders using CBC's intuitive website. This means they're an e-retailer. CBC also sells and services fountain beverage machines. However, this is a separate branch of the business that only takes orders over the phone. So we have a company that at its heart is an e-retailer, but it also has this secondary line of business where they sell and service machines. And this line of business is likely less technologically advanced because they take their orders over the phone instead of over the web. So those are all important things to keep in mind as we move forward. So with that, let's talk about Power BI. The most important question here is, what is Power BI? So the screenshot we see on the right is a Power BI report. And what this allows us to do is it allows us to do data analytics and reporting on data we have in any number of locations. It's typically considered to be a self-service BI tool, meaning that it's simple enough in its design that most power users can dig in and really get their hands dirty. But it also has a high enough ceiling that professional report developers can get a lot of power out of it as well. Another advantage it has is it can be deployed either in a cloud configuration, or it can be deployed on premises if that's what you need. So with that in mind, I'll give you 45 seconds to read our first business problem. So our first business problem says that CBC offers a lifetime warranty on all the fountain beverage machines they sell. The engineering team wants us to perform quote unquote data science on their data in order to find out which types of machines they should be selling and who they should be selling to in order to reduce their repair costs in the future. This data is currently stored in multiple Excel files on the manager's laptop. So with that, here's a question we're going to revisit over and over again. Does Power BI solve this business problem? In order to find out, let's dig into what that business problem actually means. Not everything we see here is important. Some of it's context and fluff and articles and things that don't actually get down to the core of the problem. So let's start finding out what is important. First thing I see here that's important is they want to know which types of machines they should be selling. They also want to know who they should be selling to. And their target here is to reduce repair costs. So we have questions of which types of machines they should be selling, who they should be selling it to, and their goal is to reduce their repair costs. Also important here is that these files are stored in multiple Excel files on the manager's laptop. That means that it's not a sophisticated solution. So a lot of the more sophisticated technologies might be overly complex here. So with that, we ignore everything else here and we focus on these 4 key points of the problem. So with these, let's break them down and think, why is Power BI a good solution to this problem? So the first 3, we identified our problem as which types of machines we should be selling, who we should be selling to in order to reduce their repair costs. So why is Power BI a good solution to these problems? Its self-service and reporting and analysis capabilities get to the heart of exactly what this is. In Power BI, it's very easy for us to drag and drop different slicers and measures onto charts to create all the different types of visuals we need to really be able to see inside our data. So in these cases, we could build simple measures on repair cost and start slicing repair cost by which customers tend to have the most repair costs, which customers tend to have the least repair costs, which types of machines tend to break down most often, which types of machines have the longest lifespan, which types of machines cost the most to repair. All those different types of questions we can answer in Power BI, and they can really inform us as to these are the types of customers we should be targeting, or maybe these are the types of customers we should be staying away from. Also, we identified that the data is stored in multiple Excel files on the manager's laptop. So one of the biggest selling points of Power BI is that it can easily ingest data from almost any source you give it. It has a very intuitive set of menus that you can use to say, my data stored in Excel files, here's the Excel files, boom, it's there. My data stored in SQL Server, here's the access to the SQL Server, boom, your data's there. It's very easy to use from that aspect. Also, it doesn't require an ETL developer to get that data in there. The vast majority of power users or even traditional business users could easily get access to that data and manipulate it how they need. Some additional reasons why Power BI is a really good solution to this problem is that it has a very quick implementation timeframe. Because of its very easy to use design, Power BI development goes very quickly compared to a lot of other tools. Also, it's extremely cost efficient. Power BI Desktop is completely free for anybody who wants to download it. You could get on powerbi.microsoft.com right now and download it. If you want to deploy it out to the rest of your enterprise, it's only $10 a person. That's drastically less than you'd pay for a lot of other reporting solutions and for other analytic solutions as well. We also talked about making sure that the customer can maintain the solution from a human resources perspective. And given Power BI's easy development interface, it's very easy to find people to develop these reports and maintain them for you. You don't need really high cost resources just to maintain your reports. So that's the spiel on Power BI. Let's take a moment to step into a very different avenue. So we solve one problem with Power BI. Power BI is very easy to create our reports, our charts, do our analysis. However, there are different types of business problems where Power BI might not be the right solution. So let's look at a different tool, cognitive services. First, let's talk about what is cognitive services. So cognitive services is a collection of 28 pre-built machine learning algorithms available in Azure. And they are trained using Microsoft's data. Well, Microsoft gets that data from Bing and Cortana. So anytime that you use a Bing search, Microsoft stores all that information, as well as anytime you ask questions of Cortana or talk to Cortana if you had a Windows phone or something like that, that data gets stored and Microsoft can use it to train their machine learning models. As we see at the bottom, there are 5 major categories of Cortana intelligence algorithms. We can do things around vision. So we have a lot of very good image recognition algorithms and video parsing algorithms. We also have knowledge searching. So we can use different intelligent algorithms to kind of parse through our data and make intelligent connections using the power of Bing. We can also use the power of Bing to do a lot of language analysis. So for instance, if anybody's seen the commercial where somebody holds their phone up to a stop sign that's in a different language, and their phone actually translates the picture to show stop sign in English, you can do that using cognitive services. And you can do any number of other text to speech and speech to text and all sorts of algorithms like that. Also, we can use the Bing search APIs to be able to programmatically search the web. So if we want to have a little bit more intelligence in our data, we can incorporate Bing search to tell us what the web has to offer. So with that, let's look at our next business problem. So this business problem says that CBC's website allows customers to leave comments about their orders. The customer service team wants to perform quote unquote data science on their data to find out which types of customers and or orders tend to leave negative feedback. This data is currently stored in a SQL Server table. This is a really common business scenario. In fact, I didn't even make this up. I've met with customers who have this exact scenario and want to know how to solve it. So our question here becomes, does cognitive services solve this business problem? There are a lot of different ways we could solve all of these business problems. We're not here to identify the perfect solution or even necessarily the best solution. We're simply here to talk about what are some good solutions so that we can go back to the customer and really provide options that solve their problem. In order to figure this out, let's dig through this business problem as well. So first, notice that CBC has a website. That's going to be important here in a minute. And from this website, they want to be able to find out which types of customers and or orders. So we need to be able to identify specific customers and specific orders. We need to look at their feedback. Specifically, we need to be able to identify negative feedback. This data is stored in a SQL Server table. So pulling everything else away, these are the important parts of this problem. With that, let's look at why cognitive services might be a good solution to this one. First, they have a website, and their data is stored in a SQL Server table. Some of the interesting things about cognitive services is they're accessible as Azure APIs. And APIs are programmatic interfaces that anybody with basic programming skills can hit. So seeing as how they have a website, they very likely have a web development team. And with a web development team, they can definitely hit these APIs without a problem. Also, since this data is stored in SQL Server, SSIS has some pretty relatively simple ways to hit APIs, as well as does Azure Data Factory. So with the combination of these 2 points, we can be relatively confident that they have the ability to hit these APIs. Also, they want to be able to identify specific customers or orders that leave negative feedback. So we have this table full of comments. We don't know whether they're positive or negative or neutral or all of the above. So We have these pre-built algorithms available to us, and they don't require any data or training. One of those algorithms is, I'm blanking on the word right now, but it identifies positive and negative sentiment is what it is. It's sentiment analysis algorithm. So this algorithm's already trained. We don't have to bring any data or any training to it. It can automatically tell us. We just feed it text, and it can tell us positive or negative sentiment. We also have a few other reasons. These might look familiar because they're the same reasons why Power BI is a good solution. Cognitive services, since we don't have to bring our data, we don't have to do any training, we don't have to do anything except basically click purchase. This makes cognitive services a very quick implementation timeframe. All we have to do is figure out a way to hit it. And that's relatively simple given the website SQL Server table we've seen above. They're also relatively cost efficient if you use them intelligently. And as we said, since they already have a website, the skills to be able to utilize an API are very common in the web and software development space. So those skills are easily available in the market. So with that, we've identified two scenarios so far. We've identified Power BI, which is really good at giving us those reports, giving us that self-service analysis functionality that can allow us to slice and dice our data as we need it. And we've also identified cognitive services, which provides these pre-built machine learning algorithms for us so that we can get some quote unquote data science ability without having to go through all the model building ourselves. So with that, let's look at our third tool. This tool is Azure Machine Learning Studio. It's a personal favorite of mine, and I'll probably spend more time than needed talking about it because I like it so much. But what is Azure Machine Learning Studio? So the picture here we see on the right is the Azure Machine Learning Studio GUI. It's completely web-based, and it flows very similar to SSIS or Alteryx if you've used any of those graphical ETL tools. The difference here is the goal generally isn't to bring your data in, transform it, and load it somewhere else. Your goal here is to bring data in, build it to use machine learning models, and then productionalize those machine learning models. So as we can see here, this is a completely drag and drop interface. In addition, it's what's known as a software as a service, meaning all you have to do is go to the Azure portal and purchase a Machine Learning Studio workspace, or you can, for free, Google Azure Machine Learning Studio, and you can sign up for an account just with an email address. So it's very easy to get access to this. And once you're in it, there's a bunch of different ways you can bring your data in, or they have prepackaged data you could use if you're just looking to experiment. So with that in mind, let's look at our next business problem. So this business problem says that CBC's customer churn rate has been steady for the past 3 years. The account management team can see this information using their existing set of reports and dashboards in Power BI. They want to perform data science to develop an algorithm for predicting when particular customers are likely to churn. They will use this information to reach out to these customers and attempt remediation. This data is currently stored in a SQL Server data mart. So again, back to the same question. Does this solve the business problem? Is Azure Machine Learning a good solution to this problem? In order to answer that question, let's go back to the business problem and really break it down. So, first, they have an existing set of reports and dashboards in Power BI. This is the first time we've seen a particular tool mentioned. So we've said that Power BI is a really good solution for analyzing your data. They've already got their data in Power BI. So going back to them and saying Power BI is the answer probably isn't going to go over very well. They need something a little more advanced. they want to be able to predict when particular customers are likely to churn. So there are a few things here. One, they need to be able to identify a particular customer and identify a future state of churn. So that's a prediction. That's not just tell me what happened last week. That's I need to be able to predict the future. Again, they want to be able to reach out to these customers and attempt remediation. As we said before, they need to be able to identify particular customers before it happens. Also, this data is stored in a SQL Server data mart. So whatever technology we use needs to be able to access that data as it lives. So, taking everything else away, these are the 4 parts of the problem we want to focus on. With that, why is Azure Machine Learning Studio a good solution here? First, we've seen that they have an existing set of reports and dashboards in Power BI, and their data stored in a SQL Server data mart. So as we said before, obviously Power BI is not the right play here. They need something a little bit more advanced. Cognitive services, they don't really have a pre-built algorithm that can predict customer churn. That's not part of their pre-built wheelhouse. So we need to build something ourselves. So with that, Azure Machine Learning Studio has a few advantages here. First, since it has that drag and drop interface we talked about, it's accessible to data professionals with minimal machine learning experience. One of the things we didn't call out from that picture earlier is that you actually don't need to know the specifics of how linear regression works or logistic regression or neural networks. Having that knowledge is nice, but Azure Machine Learning Studio gives you a lot of ways of kind of helping you through the problem without you having to know all the nitty-gritty of how the math works behind the scenes. So that makes it really accessible to data professionals that don't have PhDs in math or statistics. Also, it supports limited use of SQL, R, and Python, meaning if we want some more advanced data manipulation functionality, that's available, which is good because our data professionals will know SQL, and I personally use SQL a good bit for my data manipulation in Azure Machine Learning Studio. Or if you do have data scientists or people that at least know R or Python, then they can use those languages as well if they would like. Also, these Azure Machine Learning Studio experiments are easily accessible using Azure APIs. In fact, it's like 3 or 4 clicks to go from having a machine learning model built to having that model available for people to use in Azure. As we talked about before, since this company has a website and they're using SQL Server data marts, the ability to hit APIs is probably not very far-fetched for them. Next, we need to be able to predict when particular customers are likely to churn, and we need to be able to reach out to those customers and attempt remediation. That means we need to be able to, like we said before, predict the future state of an individual customer. Is this customer likely to churn in the next 90 days? Yes or no? So the whole power behind Azure Machine Learning Studio is it gives us the ability to create these targeted machine learning models. The same types of machine learning models that a professional data scientist would make in R or Python, we can make those same models here in Azure Machine Learning Studio. And that really gives us the power of predicting the future. Also, just like the tools we talked about before, it has a quick implementation time frame. Since it's got its drag and drop GUI and it does a lot of the work for you, there's not a lot of coding and testing and development that needs to be done. It is a relatively quick process. Also, out of all the tools we've talked about here, Azure Machine Learning Studio is by far the cheapest. In probably half of your use cases, it's completely free. And even if you do need to pay for it, it's $10 per user, just like Power BI. Unlike Power BI, where every user that's going to use your reports needs a license, in Azure Machine Learning Studio, the only people that need licenses are the developers. So a lot of organizations get away with 1, 2, 5, 10 licenses, whereas Power BI, you need 100, 1,000, 10,000 licenses to get your use out of it. The Azure APIs do cost money too, but they're relatively cheap as well. The whole goal here is to get customers an easy way to build these machine learning models without having to go all the way to R and Python. Speaking of R and Python. So far, we've talked about 3 narrow use cases that are relatively simple and easy to pull off, relatively easy, depending on skill sets. So we talked about Power BI, slicing and dicing, reports, analysis. If you want to be able to look at what happened yesterday and do some basic predictions of the future, like these customers tend to do this, Power BI is a great tool to start down that road. Cognitive services. If we need access to some more advanced machine learning models, and they happen to fall into a combination of the 28 accessible in cognitive services, then why wouldn't we leverage work that Microsoft has already done? Even more on that point, since the cognitive services algorithms utilize Microsoft's data, they will be far more accurate than anything we'd ever be able to build in-house. Microsoft has some of the best data and some of the best data scientists in the world. I can almost assure you their cognitive services algorithms are better than anything that we could ever hope to build in-house. And then we talked about Azure Machine Learning Studio, which is if we do need a predictive algorithm, and it isn't covered in cognitive services, and it can't be done using intuition of a manager based on reporting, then we can build our own using Azure Machine Learning Studio, which as we saw is a quick and cost-efficient way to go about it, but it doesn't do everything. You can't solve the most complex and the hairiest situations using Azure Machine Learning Studio. So let's talk about R, Python, and HDInsight. First, what are R and Python? They are the most common data science programming languages in the world. On the right side of the screen, we see two pictures. The top is R code, and the bottom is Python code. Notice, these are both programming languages, meaning that these are not accessible to your everyday user. They are programming languages, and you will need developers to code in them. They're supported in a lot of places. Microsoft has made a lot of investments to really integrate R and Python in everywhere possible because they are definitely part of the future landscape of analytics. So you can use R and Python in SQL Server. You can use Python in the Azure Machine Learning Workbench, which is different from Azure Machine Learning Studio, which we just talked about. You can also use either of these in the Azure Data Science Virtual Machine, which is something interesting, as well as in Azure Data Lake Analytics and HDInsight, which are two big data processing tools. Speaking of HDInsight, what is it? So we just talked about R and Python, and those are programming languages. They're not tools per se. You can't just use R. R has to be coded and deployed somewhere for it to run. So HDInsight is Azure's implementation of something called Hadoop. Hadoop is a big data processing framework. So when you think about how does Amazon manage its data, how does LinkedIn manage its data, how does Microsoft manage its data, they manage it on top of this Hadoop framework, something called HDFS. They all have different flavors of it, and it's all evolved over time, but it comes down to very similar mechanics on the back end. HDInsight is a big data platform as a service version of this. One of the big downsides of Hadoop in the past was that it was very difficult to instantiate and create a Hadoop cluster, especially on premises, because they require large configurations of Linux virtual machines that all need to be configured, and they need to be networked together, and you have to have control nodes and data nodes, and it's a very complicated process to install an on-premises Hadoop cluster. Microsoft made it very easy with HDInsight in that you can log into the Azure portal. You could go there right now. You could search for HDInsight. You can create a cluster. It'll ask you a few questions, and off you go. Within Azure, we have 7 different flavors. Flavors all the way from things like Kafka and Storm, which are really good for streaming data. We've got things like Spark, which is really good for batch data processing. So think of the same things you do in SQL Server in your nightly batch jobs, but scale them up tremendously, and that's what Spark is. And they've got a few other configurations like Hadoop and HBase and things like that. They also have a tool called Databricks, which gives us a bit of a management platform on top of Hadoop. So if we don't want to be down writing raw code and managing when it runs and all that sort of stuff, Databricks gives us some ability to work on top of that. One of the another big point about HDInsight is it's virtually infinitely scalable. It is the de facto big data processing framework, at least all across this country, because of its scalability. There's nothing that stops it from going 2 nodes to 5 nodes to 100 nodes to 1,000 nodes. No matter how big your data gets, no matter how fast your data comes in, Hadoop can scale with it, and that's one of the selling points here. So with that in mind, let's talk about this last business problem. So this business problem says that CBC's online sales system contains 10,000 different products and processes over 1 million orders per day. So a lot of products and a lot of orders. The marketing team would like to perform quote unquote data science to recommend additional products to their customers while they use the online system. Think of any of the, you might also like these that you see on websites. This data is currently stored in an Azure Data Lake store. So with that, our question becomes, does this solve the business problem? Let's take a look. So let's break it down. First, we see we have 10,000 different products. That's a lot of products. On top of that, we have 1 million orders per day. So when a user comes into a website, are we going to have to check 10,000 different products for that user and then do it 1 million times every day? That's a lot of processing to be done. That would brick most SQL servers right there. So with that, we want to be able to recommend additional products, which means we need to search through a lot of those products. We really can't cut corners and only look at certain products and certain orders. In addition, this needs to be done while they use the online system. So we need a way for when a customer logs into the system, as they're buying things, we need to be able to recommend one of 10,000 different products. So the system needs to be lightning fast. On top of that, it's stored in an Azure Data Lake store. As we've seen by the numbers up above and Azure Data Lake store, we have a lot of data. So we need a way to train these machine learning models using hundreds of millions of records, but we also need a way to expose that very, very quickly to the end user. So with that, let's see why R Python and HDInsight might be a good solution to this problem. First, we want to be able to recommend additional products. One of the reasons I chose this specifically, well, I guess 2 reasons why I chose this specific scenario here. One, because it's very common. Virtually every customer I go into says, oh, I want to be able to have a recommendation algorithm for my customers. Amazon does it and it's so great, and I want it to. Azure Machine Learning Studio, while that's typically my go-to for most situations, it doesn't do a very good job at building recommendation algorithms, especially ones that need to scale really, really heavily. So one of the advantages of R and Python is that almost every imaginable algorithm is accessible in there. Basically, if it's been invented, you can probably find it somewhere in R and Python. In addition, we get access to something that Azure Machine Learning Studio doesn't have anything resembling, and that's deep learning. So to take 30 seconds to talk about deep learning is basically very complicated neural networks that's used to allow computers to replace intelligent thought with incredible amounts of processing. So deep learning is very often used for, like, image recognition is very often built on top of deep learning frameworks because it allows us to really break down a picture into all of its different components and manipulate it as much as we need to get some very advanced insights. Also, part of our requirements, we're looking at this size and speed problem here. So we have a lot of products, a lot of orders, and we need them fast. So we need a framework that can really, really scale. Scaling something that probably is outside of the reach of things like SQL Server and Azure Machine Learning Studio. So one of the advantages we talked about of HDInsight and the Hadoop framework in general is that it's capable of consuming massive amounts of data depending on your configurations. In fact, we name dropped things like Amazon and LinkedIn and Microsoft before, because a lot of the current Hadoop configurations were actually invented by the people that work at those companies. Because they have massive data problems, and that's exactly what Hadoop is meant to solve. Also, some additional interesting points there. If we use a single set of languages, like R and Python, we saw earlier that we can use those same languages in a lot of different tools. Yeah, we can use them in HDInsight. We can also use them in Azure Data Lake Analytics. We can use them in the data science VMs. We can even use them in, we can use R inside Power BI. So having the ability to use the same language across a lot of different tools gives us a lot of different options. One, it means we can have a single set of data scientists that can solve our problems in all of the different tools. Also, it means that if we build code artifacts or models, we can use them in all of our different tools because it's all the same language, and that gives us a lot of flexibility. Also, these skill sets are rapidly increasing. In fact, I work for an organization that just gobbles people like this up. So these types of skill sets are coming out of the woodwork now, and organizations are really latching onto them. So with that in mind, what's the takeaway here? We've talked about a lot of different tools, 7 different tools, in fact. How do we take all this away with us? So let's think about this chart here. We have a chart on the vertical axis. It shows scope of implementation, meaning how much do we want to do, and how hard is it, and how long is it going to take? Those different scenarios. And then on the bottom, we have cost of ownership. Things like what type of skill sets do I need to maintain this? How much is licensing going to cost? All those different types of questions. The first 3 tools we talked about, Power BI and Azure Machine Learning Studio and Cognitive Services, they're towards the bottom of this chart. They have the limited scope, but they're also relatively easy to implement. And up at the top of the chart, we have these really flexible tools of R and Python and HDInsight. They have that extreme flexibility and the really large scope, but they also come with a higher cost. So as we said, we can think about the bottom set of tools as fast, easy, but limited scope. Use them if you can, and if you can't, then migrate over to some of the slower, more difficult tools that can almost assuredly solve your problem. So with that, I'm going to leave you with the same question we started this whole thing with. As consultants, this is the only question we need to be able to answer. It's not, how do we solve this business problem? It's, what's the easiest way to solve this business problem? What's the way that the customer will appreciate the most? So with that, I definitely want to thank everyone for coming and listening to this session, and I'm open for questions now.
Thank you, Brad. And to our audience, if you have questions, please post them in the questions box in the lower right-hand side of your screen. I have none open right now, but please feel free to submit. And Brad will stay online for a few minutes here. If you have to leave, just wanted to let you know that you can stay tuned for our next session, which is Predictive Analytics Solutions using R and SQL with Carlos Bossi. He'll be the speaker. And thank you for attending. We'll stick around for a few minutes if you decide you want to post questions. And once again, thanks, Brad Llewellyn. Really appreciate your presentation here. Nice job and very informative. Thank you, everyone, for attending. Okay, I do have a couple of questions that have come up. One is from David Wade, who is asking if you can recommend any specific YouTube or channels or other learning tools.
Does he have a specific thing he wants to learn?
Not specified.
Yeah, I mean there are great places to learn. I personally love Microsoft Virtual Academy. If you're ever looking for Microsoft specific training on things, and I do love the PASS webinars as well are great places to learn. But if you could be more specific, I might be able to help you a little more.
Okay, I'll watch to see if he provides additional information. Next question is, what kind of programmatic experience is required to be able to use any of these tools and be comfortable with making best models, comparing the power of each of these techniques?
So that question really gets to the heart of the presentation, in that it really depends on which tools you're using. For instance, most people who are even slightly technical can pick up Power BI pretty easily. Cognitive services is definitely going to require some software experience. As Azure Machine Learning Studio, you need to be a little bit more of a data professional, more so than Power BI, but you definitely don't need to be a lifelong programmer. The R and Python and HDInsight route, those are developer tools. So you would definitely need some software or statistical experience to use those.
Okay, and that question was asked, by the way, by Jayakrishna Tangarala. Another question from Eduardo Taka. His is it possible to share this presentation? And Eduardo, that is, the recording is going to be available in about 2 weeks. You'll be notified via email. I'm wondering if he's asking if the PowerPoint itself would be available.
So that should be on PASS's website right now.
Okay, great. David Wade, thanks you for your response. And our next question is, this is from Anthony Saltis. As for training, are there any sources that have good sample sets, cookbook examples, and applied methods discussed?
Oh, that's a great question. So that would definitely be tool specific. For instance, if you go to powerbi.microsoft.com, they have sample data sets available. In fact, they have sample reports available that you can reverse engineer to see exactly how they were built. Cognitive Services has documentation, and that's about it. Azure Machine Learning Studio has a bunch of built-in sample experiments, and you can also go to the Microsoft AI gallery. You can Google that, and they'll have a list of community built experiments that you can use. The more interesting side of that is if you're getting into the R and Python side, there's a website called Kaggle, Kaggle, and they host competitions where somebody will post a data set and a particular problem they want to solve, and you get people from all over the world that try to solve it. So you can see how an amateur might try to solve it, all the way up to some of the best in the world. So it gives you a really good experience of seeing how other people would solve a problem using any number of different tools.
Okay, and Jaya Krishna, thanks you for your response, and it's a good presentation. Anthony Saltis also thank you for your response. Okay, with that, we should move on to the poll, and that should come up very shortly here.